All right, number 2 on the concept mastery worksheet. So we have this kid standing on a skateboard. Now look, I'm a horrible artist, so this box right here represents the kid on his skateboard because I don't even want to attempt to draw that. So we got kid on a skateboard represented by the box, and then here's his friend pushing. Okay, so let's go through the mechanical energies. Does the kid on the skateboard start with kinetic energy? Nope, that goes away. Does the kid on the skateboard have potential of gravity? Because notice everything in this problem takes place on the 0 point, right? Everything's on the 0 point, so we have no potential of gravity. Do we start with any spring energy? No spring energy. So how much energy, how much mechanical energy does this kid on the skateboard start with? 0. Has no mechanical energy. Then along comes his friend, and the friend exerts a force on the friend here exerts a force on the kid standing on the skateboard, and then that's going to give this the situation some mechanical energy. Now we're told in the problem right here, the friend does 600 joules of work. So that's what this is right there. Remember, what's work non-conservative? It's the work done by anything other than gravity or spring. Does the friend qualify as something other than gravity or spring? Yeah. So this work non-conservative, is it going to be plus 600 or minus 600? Is the work being done in the direction of motion or against the motion? In the direction of motion. So that's going to be positive 600. Okay, now let's go through our final energies over here. So over here, the friend has pushed for 3 seconds. Do we have kinetic final? Is this moving? Over here, it's not? Yeah, because the friend just pushed for 3 seconds, right, with a force doing work. So we have kinetic energy over here because it's in motion. Okay, do we have potential of gravity over here? No, that would be if he went up a hill. So we have no potential of gravity. Any spring energy? No spring energy. So what we're left with is this, the work non-conservative, which let's just call that the work of the friend. The work of the friend is going to be converted into what? Kinetic final. Right? And we know that the work of the friend is equal to 600 joules. So that's the answer to the first question right here. 600 joules is equal to kinetic final. So the answer to the first question is 600 joules. Second question, find the final velocity of the kid in the skateboard. So what's the velocity over here? So how do we do this? Well, kinetic energy has an equation. The equation for kinetic energy is 1/2 mv squared. So the velocity is going to be 2 times 600 joules over m, which is 40. The mass is 40. Square rooted, right? And then this comes out as 5.5 meter per second. Okay? And then the last question, find the power output of the friend. So what's the definition of power that we want to use here? Power is work done over time. So how much work did the friend do? 600 joules. How much time did that take him? It's right here. 3 seconds. So this gives us 200 joules per second, which is 200 watts. A joule per second is a watt.